We are spending trillions of dollars to build offshore wind farms, but the base of almost every tower hides a silent chemical compromise. Locked inside a sealed steel cabinet at the foundation of these massive towers is a gas called sulfur hexafluoride, or SF6, which is the most potent greenhouse gas ever discovered. Unlike the carbon dioxide released from fossil fuels, SF6 does not decay. Once it escapes into our atmosphere, it remains there, trapping heat, for over 3,000 years. To understand the sheer scale of this threat, releasing just 1 single kilogram of SF6 has the same warming effect as 23,500 kilograms of carbon dioxide. This impact is less like a single cup of hot coffee warming a room, and more like an industrial boiler running at full blast in every building on your street simultaneously. Yet, the wind industry has quietly packed tens of thousands of these reservoirs into turbine towers across the coastlines of Europe, North America, and Asia. To understand why engineers deliberately put this super pollutant inside our greenest machines, you have to look at the immense voltages required to run a modern power grid. A standard household light switch is simple because the voltage is low enough that air easily stops the current when the contacts separate. But a modern wind turbine operates at up to 66,000 volts. At this scale, when you switch the power off, the electricity jumps. It tears through the air, creating a blinding plasma arc that burns at over 20,000 degrees Celsius, hotter than the surface of the sun. Without an immediate way to quench this arc, it will vaporize copper, melt steel, and destroy the entire control system in milliseconds. In 1900, a French chemist named Henri Moissac combined sulfur and fluorine to create SF6, finding that its heavy, dense molecules acted like an instant smothering blanket over electrical arcs. By the 1950s, SF6 switchgear became the global safety standard. Because the gas was so efficient, safety cabinets could be built small enough to fit inside cramped indoor substations. Decades later, when the wind boom began, developers faced a major spatial constraint. A wind turbine tower is a narrow steel cylinder, and packing 66,000 volts of safety gear inside a 10-foot base left them with effectively one option: SF6 switchgear. While a few sealed units in a centralized coal plant were easy to monitor, the wind transition distributed thousands of individual switchgear cabinets across remote marine environments. Buffeted by high winds and battered by corrosive salt air, these turbines vibrate constantly, causing metal seals to expand, contract, and slowly degrade. Industry estimates place the resulting leakage rate at about 0.5% per year. That sounds negligible, like a car tire slowly losing air over 6 months, but a single turbine switchgear cabinet can hold 100 kilograms of gas. A 0.5% leak from just one machine releases the equivalent of 12 tons of carbon dioxide every single year. This invisible feedback loop is why the European Union's historic ban on new SF6 switchgear officially took effect on January 1, 2026. The industry did not wait for this deadline to scramble for solutions. Because normal air is too light to stop a 66,000-volt arc, engineers had to redesign safety systems from the ground up. Siemens Energy resolved this by combining two technologies: a vacuum interrupter to quench the arc in a sealed chamber with no air to jump through, and highly pressurized clean air, a simple mix of nitrogen and oxygen, to insulate the surrounding conductors. With a global warming potential of exactly 0, this clean air technology has already moved past the laboratory. For the massive 2.9 gigawatt Hornsea 3 wind farm in the United Kingdom, Siemens Energy is supplying 197 bays of this SF6 free switchgear to help power 3 million homes. Other giants have taken alternative routes. General Electric has deployed fluoronitrile gas blends that perform identically to SF6 but reduce the carbon footprint of the equipment by 95%. Meanwhile, ABB has secured framework agreements to supply solid insulated SF6 free switchgear to major European distribution networks like E.ON in Germany and Enedis in France. For the tens of thousands of older turbines already spinning with SF6 inside, the transition remains practical. The new regulations do not force developers to prematurely rip out functioning switchgear, which would trigger massive grid downtime and tons of premature electronic waste. Instead, Existing units are permitted to run their 20-year lifespans, provided all maintenance uses closed-loop recycling to capture the gas before it escapes. The chemistry that made the wind transition possible was born in a Paris lab over a century ago. Today, as the engineering replacements roll out at grid scale, the wind industry is finally replacing its dirtiest secret with clean air engineering, proving that green technology can live up to its promise.